Good morning, everyone. I am S. Mansoor Basha, and along with my team members Konda Naveen, Shaik Fayaz, Boya Shivaraju, we are presenting our project titled Smart Factory IoT based Industrial Monitoring and Control System. This project was completed as part of our IoT and Embedded System Internship with the Team Emertxe, where we worked on real time monitoring using technologies like Arduino, MQTT, ThingsBoard, and PiximLab. Coming to internship overview, during this internship, we gained hands on experience in IoT and embedded systems. We learned how to integrate hardware sensors, embedded programming, communication protocols, and cloud platforms. We also built a complete end to end smart factory monitoring system, which helped us understand real industrial workflows. And coming to understanding sensors, sensors are the foundation of any IoT system. They convert real world physical parameters like temperature, humidity, and motion into electrical signals. These signals are used for automation and smart decision making, which is essential in industrial environments. The DH22 sensors measures both temperature and humidity using a digital signal, so no ADC is required. It provides high accuracy and stable readings. The LM35 sensor is an analog temperature sensor that gives output as 10 millivolts per degree Celsius. It requires ADC conversions in Arduino and is simple and reliable. Coming to additional sensors, we also used additional sensors to simulate real industrial conditions. The PIR sensor to detect human motion for safety monitoring. The LDR sensor detects light intensity. The potentiometer is used as a vibration simulator to represent machine conditions. The Arduino and PiximLab. We used Arduino IDE to write programs in embedded C and C++. We uploaded and debugged the code using the serial monitor. We also used PiximLab to simulate the hardware environment, which allowed safe testing without physical components. Now, the next part of the presentation is continued by Mr. Naveen.
MQTT protocol and JSON. We used MQTT and a lightweight communication protocol based on the publish subscribe model. Arduino publishes sensor data and the cloud subscribes to it through a broker. Data is sent in JSON format, which is structured and easy to process. And next, ThingsBoard platform. We used ThingsBoard as the IoT cloud platform. It allows device management, dashboard creation, and real-time monitoring. It also supports a rule engine and RPC for remote control. And next, data flow and networking. The system works in a pipeline. Sensor collects data, Arduino process, and data are sent to via MQTT, and last, cloud displays it. The Ethernet shield provides stable internet connectivity using TCP, IP, and RJ45 cable. And next are resume and career readiness. In addition to technical skills, we also learned resume building using latex. We understood how to highlight skills and project experience effectively. We also gained insights into the job market in IoT and embedded systems, where hands-on experience are highly valued. And the next part will be continued by Mr. Fayaz.
Coming to the learning summary, overall we gained knowledge in sensors and programming using Arduino, communication using MQTT, JSON, cloud integration using ThingsBoard, and professional skills like resume building. Coming to the problem statement, traditional industrial systems face several issues. There is no real-time monitoring fault detection is delayed and there is no remote control. This leads to inefficient safety risks and increased operational cost. And coming to the proposed solution, to solve this, we developed a smart IoT based monitoring system. It integrates sensors, Arduino, and cloud to provide real time monitoring and remote control. And coming to the system architecture, in our system, data flows from sensors to Arduino, then to cloud using MQTT. The cloud processes and displays data on dashboards. Control commands can also be sent back from cloud to Arduino. Now, next part of the presentation will be continued by Mr. Boya Shivaraju.
Sensor nodes. We designed two nodes. Node 1 monitors the production line using DHT22, LM35 and vibration sensor. Node 2 monitors warehouse conditions using DHT22, PIR and LDR sensors. Now coming to the working process. The working process is simple and continuous. Sensors collect data, Arduino processes it and MQTT sends it to the cloud. The cloud then displays it and allows monitoring in real time. Alerts and automation. We implemented threshold based alerts. For example, if temperature exceeds 35 Celsius, an alert is generated. If the vibration is high, the warning is given. If humidity is high, the warning is triggered. This helps in early detection and automation. Now coming to the importance of system. This system provides many benefits. It enables real-time monitoring, remote control, reduced downtime, improved safety and cost efficiency. Future scope and conclusion. In future, this system can be expanded to large industries and integrated with AI for productive maintenance. This project helped us build strong practical knowledge in IoT and embedded systems. Now, the implementation and simulation of smart factory monitoring system will be continued by my friend Mr. Mansoor Basha.
Now I am going to explain our project on the smart factory monitoring system. In this, first we will see the node 1 production, which is a production line monitoring. In this part we have written a Arduino code here. This is the code for that, and in this, after this, we have connected the connections in the Pixim lab as per our requirements, and here we will upload a hex file, and this hex file is created in Arduino before. After uploading this hex file, this whole data is being sent to the ThingsBoard through MQTT connection. The connection between this ThingsBoard and the Arduino components there is connected through a access token in the ThingsBoard by placing it in the Arduino code. Now when we change the parameters here, like the LM35 parameter and the DH22 parameters, now let us see these values in the ThingsBoard. Now we will see this in the ThingsBoard entities and in the devices. There we have created a device called Node 1 Smart Factory. Click on that, and in that we will see latest elementary. There we can observe the values. We can see the values of humidity, LM35 temperature, machine status and all others. Now we will change the parameters again so that we can observe the changes in the parameters. We have changed the LM35 temperature and humidity. Let us observe them. As you can see, the values just now changed, and as this is a production line monitoring system, we have placed some of the alarms here so that we get some alarms when there is some problem. Like we have placed the alarms for temperature and vibration. If the temperature is above 70 degrees and the vibrations are above 700, then we get alarms. So let us go to the Pixim lab and change the parameters. When the temperature is above 70 and vibrations are above 700, then we will get the alarms in the ThingsBoard, and we can see the alarms here in the ThingsBoard. See, we can see that in the node 1 we have getting the alarms like critical and critical. So these are the things we observed, and we can observe these things all also in dashboard by using a colorful widgets. We have already created a dashboard called production line for this node 1. Here we can observe the temperature, humidity and the graphs also. And here there are LEDs which are used to monitor the machine status, relay status and sensor errors and other temperature values, and we have also placed a table for observing the critical values. Here as we can see the machine status is on. It means the data is being sent to the ThingsBoard. Let us see the sensor error here. We can go to Pixim lab and change the properties of one of the sensor so that we can see that it was before words 2, now it is 3. So if we change any value, we get here a yellow. Yeah, you can observe here as the connections are wrong, the yellow LED is on. Now when we observe it in the ThingsBoard, we can see there is an error. So the sensor error LED is on and the machine status is off because there is no data being sent over here. Now let us change it to the correct connection here again, which is to pin 2. Okay. Now when changing any value, now let us check in the ThingsBoard. Here we can see the machine status is on and the sensor error has gone. So our connections are correct. Now we can control this in using a relay in this ThingsBoard also. After owning this relay, we can observe in Pixim lab the LED of red LED here is on, which is a relay status. This is used to control the node 1 because we are not there at that time. We can control it from anywhere. Then let us see after switching off in ThingsBoard, switching off the switch control, then we can observe the red LED before words has gone off. It will take some time. It will take some time for going. Now let us observe in dashboard. These are the parameters we have there. We can see the temperatures, humidity, machine status, relay status, temperatures and sensor errors and vibrations. and below there is the table for the errors. It means alarms which we can observe. So this is how we do the node 1 production line. Next part is continued by Mr. Naveen. Thank you. Now we are going to simulate the warehouse monitoring system, and this is the code which we have written in Arduino Uno, and this is the .ini file and all other useful files which are required here, all are here, and we create the hex file needed also here. Now we go to PiximLab and we do the connections as we required. After that, the data is being sent over to the ThingsBoard, cause the ThingsBoard and the data sent over here are connected through a MQTT through a access token. Now let us see the values in the ThingsBoard. In ThingsBoard devices, we have already created a device called node to warehouse. In that latest telemetry we can observe the data like door, temperature, humidity, LDR values, all those. Now let us check a change in value in here by changing the value in PiximLab. Now let us change temperature, humidity and change in LDR. Now let us observe in latest telemetry. As we can see, the values have been changed. Now let us set the sensor error to 1. It shows if any connections are wrong, then the sensor error will show 1. Now let us test that. Go to PiximLab. Here let us change the connection of DH22 from pin 2 to pin 3. Then change a value. Then we can observe the yellow light blinking. It means the connection is wrong, and we can observe it in the ThingsBoard as sensor 1. It means the value is not being transferred and this is an error. So we can get rid of it by reconnecting the correct connections in DH22 properties to second pin. Then OK. After changing a slight value, we can observe the yellow light is not blinking, and in observing in ThingsBoard we can observe there is no error. It means all the connections are correct. As this is a monitoring system, we created some of the alarms here. We created mainly 2 alarms, which are is dark alarm and high humidity. Is dark alarm will show critical when the LDR value is 300, and high humidity alarm will show critical when the humidity is above 85. Now let us observe these critical alarms by going to PiximLab and taking the LDR values and the humidity to above 85. As we have already implemented a logic where if the humidity is above 85, then the ventilation relay will automatically open. Now let us see if there are any alarms showing there. In ThingsBoard, go to alarms. Here we can observe that the node to warehouse is critical for high humidity. So that is the error alarm we are showing there. Now we can also observe all these things in the dashboards. Go to dashboards, and we have created a dashboard called warehouse monitoring node 2. Enter it. There we have many of colorful widgets for humidity, temperature and LEDs to check if those things are on or off, and switches and some of the time series tables and time series charts. And let us see if the motion is detected, cause here it is already off, so let us change it in the Pixim lab. Now let us see. As we can see, the motion LED is on. It means there is someone breaking into the warehouse, or like that we can assume that. So let us off this motion in Pixim lab. And off this door switch also. Then observe in ThingsBoard. Then we can see the door is off and motion will be off in some time. As you can see, the motion is also off. Let us observe a temperature value in the time series table. Let us go to Pixim lab and change the temperature here. Then again go to ThingsBoard. Then we can see the change in the temperature in the table. Like this, there are many changes we can observe. And this is the whole type of the process we are implementing in this warehouse monitoring system. And these are the both monitoring systems, node 1 for production line monitoring and node 2 for warehouse monitoring. Now we are monitoring a factory. So these both warehouse and production line are integrated together. So for that we are creating another dashboard called smart factory. In that smart factory we have already created widgets to observe the values of node 1 and node 2 and also time series chart. So let us place the Pixim lab windows side by side and observe the changes there. This is node 2. Now this is node 1 Pixim lab. We have taken in a single window. In ThingsBoard, these are the values. Now after changing the values in here slightly, we can observe some values being changed. Now also changing in node 1. Then observing the values in ThingsBoard. It will take some time to get updated. Yeah, as we can see, the things have updated because here the values are of node 1 are same as the table here, and below is the time series chart for node 1 and node 2 observing. So this smart factory monitoring system helps us to monitor our factory even though we are afar, and helps us to keep our goods and productions and everything in check and safety. So this ThingsBoard and all this is very useful. We would like to thank the management and our mentors especially for giving us this valuable opportunity to present our project. We are also grateful for this internship, which helped us learn IoT concepts and gain valuable practical experience. It has been a great learning journey for all of us.